Welcome to another fascinating journey into the world of mathematics and infinite possibilities. Today, we're delving into the incredible realm of infinity with some truly mind-blowing facts. Our first fact is the idea that not all infinities are the same. In mathematics, we've discovered different sizes of infinity, and it's a concept that challenges our understanding of the limitless. Two different infinities are the same size if you can link each element of one infinity to the other infinity. For example, there are as many even numbers as there are numbers. But if you can't link each element of an infinity to the other, both infinities are different sizes. For example, you can link every natural number to a real number, but the list of real numbers will never be complete since you can add an infinity number of decimals. So the real numbers represent a bigger infinity than the natural numbers. Sounds logical, right? Then these guys came along and proved that infinities are the same size. Maliaris and Shaler outline a proof, that very rare instance of a provable equality among orders of infinity, such that every element of F contains A except for a finite error. Sounds logical? I'm not going to pretend I can wrap my mind around the proof, but for anyone who's interested, you can follow the QR code to an article about their proof. The universe, too, has its own infinite story. Scientists speculate that our cosmos may extend indefinitely, with countless galaxies, stars, and planets, spanning forever. However, since the universe has a finite age, we can only observe a finite volume of the universe. The universe's vastness challenges our comprehension of infinity. With billions of galaxies, each containing billions of stars, the universe is thought to stretch beyond our current observations. The notion of a potentially infinite cosmos reminds us of the profound mysteries that still await discovery. Or 293, or 567, or even numbers or odd numbers, you get the gist. This fact might seem counterintuitive, but it's a fascinating result of the one-to-one correspondence between the set of natural numbers and any set of natural numbers we mentioned before. Both sets are infinite, demonstrating that infinity comes in various sizes and can be counterintuitive in its vastness. Called the Galileo paradox after its famous discoverer, this thought experiment shows that the size of infinity cannot be changed using the crude tools of basic arithmetic like division, or the addition of finite numbers. Just as the number of infinite whole numbers is on a whole different level of infinity than the number of irrational numbers, there are levels of infinity above that, another one above that, and so on, up through, you guessed it, infinity. This might sound perplexing, but it's one of the fascinating aspects of infinity in mathematics. In mathematical terms, you can take an infinite series of numbers, for example, 0, 1, 2, 3. And create a larger infinite series by taking all the different possible combinations of the numbers in the original series. Mathematically, this is referred to as a power set. So, for the whole numbers, the power set would not only include 1, 2, 3, but also every conceivable combination of numbers in that infinite series, including 1 billion and 1, 2, 13, 2 million, and so on. Once you've created the first power set, there's no reason you cannot form a power set of the power set, or a power set of a power set of a power set of a power set, and so on, reaching into higher levels of infinite complexity. It's a mind-boggling concept that underscores the boundless nature of infinity in mathematics. Yes, you read that right. But in case you didn't hear it is again. There is a level of infinity in which infinity plus 1 does not equal 1 plus infinity. Let that sink in for a while. The technical proof of this supersedes the abilities of your humble author's intellect, but let me give you an example that I can wrap my mind around. Imagine you have a magical bag that can hold an infinite number of toy cars. You keep adding more and more toy cars into the bag, but it never gets full. It's like a bottomless bag. Now, one day, someone gives you one more toy car. When you try to put this extra car in your bag, it just disappears. That's because your bag can hold an infinite number of cars, and adding one more doesn't change anything. It's still just as full as before, completely infinite. So, in this special world of infinite things, adding one more doesn't make a difference because infinity is already as big as it can be. That's why, in this world, infinity plus 1 is still the same as infinity. It's like having a super-duper big number that never ends, and even if you add a tiny number to it, it stays super-duper big. So, infinity plus 1 doesn't equal 1 plus infinity because infinity is just too big for one little number to change it. These mind-blowing facts remind us that infinity is an awe-inspiring concept that continuously challenges our understanding. There's no end to what we can explore and discover. If you enjoyed our journey today, don't forget to like, subscribe, and share your thoughts on infinity in the comments below.